So remember, here's the law of sines in all its glory. Side A over sine of angle A equals side B over sine of angle B equals side C over sine of angle C. Angles are designated by capital letters and sides are designated by small letters. And of course, angle A is across from side A, angle B is across from side B, angle C is across from side C. Officially, for the law of sines, you need two angles in any side, AAS or SAS, and two sides and an angle opposite them, side-side angle. Remember, if you have side-side angle, you could run into trouble with the ambiguous case if the second side A is larger than H but less than B. We put that to bed. I tend just to look at my fractions and try to make one fraction equal to another and say, I need to find 3 out of 4 in order to make it work. If I have 3 out of 4, I can use the law of sines. It works for any triangle. That means a non-right triangle, an oblique triangle, or a right triangle. Remember, right triangle trig, when you have that right angle, you can use SOHCAHTOA. Sine is opposite over hypotenuse, cosine's adjacent over hypotenuse, and TOA is tangent is opposite over adjacent. One last reminder, don't try to find the largest angle of a triangle using the law of sines, because remember, when we say we're using this inverse sine, we're trying to find the angle, so we take inverse sine of the ratio, and our result, the input is the ratio, that's our domain, the output is the angle, and it must be between negative 90 and 90 degrees, inclusive of the endpoints. But we don't have negative angles when we're talking about triangles, so it's got to be actually an acute angle. So don't try to find what you think could be an obtuse angle using the law of sines. Law of cosines, that's our next topic. So this is one I would suggest you know. In order to not be frustrated, to have enough information to use the law of cosines, you need side angle side or side side side. Now that's not side any angle and any side. That's directly a side included angle and side, or side, side, side. Well, let's check out the law of law of cosines. Here is an oblique triangle. It could be any triangle. Could be a right triangle, could be a non-right triangle. A squared equals B squared plus C squared minus 2BC cosine A. Well, how do you make sense of this? Look at this. We're starting here with A. We're saying this squared is equal to this squared plus that squared minus 2 this, that cosine of the angle crossed for it. So if I am going to find something about A, side A, put there, I'm looking to the opposite side angle side. Oh, that's very convenient because that's one of the things, that's one condition I would need to use the law of cosines. How about B? B squared is equal to A squared plus C squared minus 2AC cosine B. How do I remember that? Look at this. B squared is equal to, think about the opposite side angle side. B squared is equal to A squared plus C squared minus 2AC cosine B. Oh, I could just look at the triangle and figure out. How about, I'm not going to look at the last one. C squared must equal A squared plus B squared minus 2AC cosine, C squared must equal A squared plus B squared minus 2AB cosine C, and it is. Also, look, if we start with side A, we end with angle A. Start with side B, we end with angle B. Start with side C, end with angle C. If you're going after the angle, so you're going to find this angle here, A, B, or C, depending on what formula you use. The range, remember when we introduce inverse cosine, we're taking inverse cosine of a ratio, and that ratio must be between -1 and 1. And we're looking for the angle. And our range here, provided our domain is all squared away, our range will be between 0 and 180 degrees. Remember, that was the top of the muffin if you think about the unit circle. So the implication of that is we can hunt for obtuse angles using the law of cosines. There's our takeaway from that.